the different forms, we have to remember what some of those forms were. I never erased all that completing the square. Someone must have erased all that. Oh well, not very good. We need it for today. So we've got your standard form, ax squared plus bx plus c. We had vertex form. That was your h and k, which is this here. Your x minus h quantity squared plus k. And then you also had your intercept form, y equals a, x minus p, x minus q. And we wrote those things through. Yes, sir?
We're supposed to know those.
Should, yeah. Yeah. So here's what's going on. What you're going to be given is write the quadratic function in vertex form. It's going to ask you to go to that vertex form. It's your a, h, and k. They're going to give you a vertex and a point. So if you start to think about when you're looking at that, if you're working with a, h, and k, and you know that your vertex lies at 2, -3, as I substitute into the generic form of the equation, I would automatically get y equals a. If my vertex is at 2, -3, do I write x plus 2 or do I write x minus 2? Very good, x minus 2. And then it's -3 for k, so what do I write? Very good. What don't you know then? The a value. All right, you don't know the a value. Exactly. All you have to do to find the a value here is substitute in the other point that they give you. They gave us a point on the graph is 4, 1. They gave you a set of ordered pairs. So what you do is you write out with your h's and your k's, and then you take your ordered pair of 4 and 1. 1 equals a, bless you, 4 minus 2, quantity squared minus 3, and you solve that for a. What's 4 minus 2? The ordered pair. 4. I have the ordered pair that was given to me in the problem. Right here. So we get, what's 4 minus 2? What's 2 squared? So I have 4a squared minus 3 equals 1. Now what did I do? Why did I square that? I don't know why I squared that. Thank you for paying attention. Yay! Now what do you do? What?
On the other side.
What's A? 1. A does not equal 0. A equals 0. You have a horizontal line. So now, what's the last thing you have to do? Right, just rewrite it out. Now, if your a value is 0, can you just write y equals x minus 2, 1a squared minus 3?
Yes.
A equals 1. If a equals 0, you'd have a horizontal line through 3. -3, excuse me. And that's it. What we're doing here is you take your h and your k, substitute in, as well as substituting in the given point that you are shown.
Wait, that's the answer right there?
That's the equation, working backwards from what they're showing you.
Wait, why did you write 1, sorry?
Because it's 1 is a. If I put a 1 here, does it really do anything?
Okay, so just
Okay. If it was 3, I'd put the 3 there.
did you put 3A or just
Just 3. Because a is 3. Okay. Okay. Same idea. If I have a vertex at 2, -1, and my point is 4, 3, I'm going to write this into vertex form. When I write in vertex form, and I know you were asking about this last game, what I would do is, if you're not sure about what those formulas are, write them out a couple of times. I guarantee if you write it out 3, 4 times as you're doing your homework here, you'll memorize it real quick. Y minus a, or y equals a times the quantity x minus h squared plus k. Fill in the blanks. If you want to fill in the blanks right away, given all 4 of those values, that's fine. Nothing wrong with that. The mistake that you guys might make is just accidentally switching an x and a y or an h and a k. Just watch it. Okay? So I know that the point is your x and your y. Here's your h and your k. And fill it in. So I know, let's see, 3 is a. 4 minus 2 minus squared minus 1. What's a? Yes, sir.
On the test, would you use some kind of button saying blah 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 and then square?
Yes.
So you can't just, so
I will ask you to complete the square, yes. I will ask you to complete the square. I will probably ask you to complete the square with leading coefficient, not equal to 1. Which means all you gotta do is divide it out. We'll worry about that next week. So when you square this out, you get 4 minus 2 is 2. 2 squared is 4. Boy, that was convenient. What's a again?
Somebody look like one.
Yes, sir.
so are we always gonna write it in vertex form?
Unless it asks you to write it in intercept form.
Okay, so
And that's the next example. That's the next example we'll get to.
So, anytime you do intercept form, or
Yeah.
so do you have to be using vertex form?
It's going to ask you to write it in the specific form. We have 3 forms to write equations out today, and we're going to do examples of all 3. This is how you do your intercept form. So y is going to equal x minus 2 quantity squared minus 1. And that's how your answer would look. When I write it out in intercept form, well, you have to be given what? You got to be given your intercepts. So if I'm giving out intercepts, and what do you think the same thing you have to do? We still have to solve for what? A. When you're working with intercept form, remember, that is y equals a times the quantity x minus p times quantity x minus q. Your p's and q's are the zeros. Those are the intercepts. So if my intercept is at -2, it would be x plus 2. If my intercept is at 3, it would be x minus 3. Very good. And once again, I know that the point that the parabola goes through is -1 and 2. So what do you think I have to do with that -1 and 2? Plug it in for what? X's and Y's. So I know that 2 is going to have to equal a, and I have to substitute back in here. -1 plus 2, -1 minus 3. Watch your signs. I'll try and do it once. What is it? You get 1 times -4. So you have -4a is 2. So what's your value of a? Very good. -1/2. Once again, it's asking us to write this into intercept form. So your final answer should look like it's in intercept form with x's and y's back in there with your new a value and your zeros. So once you solve for a, you just go back to it, and your final answer would be y equals -1/2 x plus 2 x minus 3. Once again, it's a matter of you have 5 variables in this equation if you're looking at it. Or 6 of them, excuse me. You know 5 or 4 of them, whatever it is. I'm sorry, there's 5 variables because x is repeated. Good morning. You know 4 of them, solve for the other, and just rewrite. It's very similar to when you guys would write out slope-intercept form or y-intercept when you're given slopes and intercepts and things like that. You had to go back and rewrite. It's kind of the same idea. You're solving for one of the values and going back to it. I know some of you guys used, when you did slope-intercept form, instead of doing point slope, some of you guys solved for b and then just rewrote it. It's kind of the same idea. Yes, sir?
Are we getting our quizzes back?
Tomorrow, because then everybody's finishing them out today. I apologize because it's just been, I hate giving things back without people taking it, and that's the downfall of tests and quizzes. So, let's look at one more like this, and then we'll get to the standard form, which is usually the most complex. So I have zeros at -2 and 2. I have zeros at -2 and 2. And my point is at -4 and 8. Oh, real quick question. If my zeros are at -2 and 2, where's my axis of symmetry? Very good. Very good. So, substitute in again. Or but you know what? Let you guys finish this one up. Flat right there. You get 2/3?
Yeah.
Yeah. So if I get A, what? Miss a sign?
Oh, I haven't even done it yet.
Oh, I'm sorry. I thought you were going to.
Took a lot of time.
You can go on.
So if your A value is 2/3, your final equation would look like y equals 2/3 times the quantity x plus 2, x minus 2. And when you have x plus 2, x minus 2, it doesn't matter which one goes first. It doesn't matter. As long as the A value is right and your intercepts are correct, you're fine. Because the axis of symmetry is yes, sir. What's the last chapter this semester? 9. Did you go? We go 9 then 7. Did you get it all right then?
So we don't do 8?
I got them all right.
We do 8 later. We go a little bit out of sequence because what we do in this class is we build into this course a lot of the material that's seen in the springtime. The book doesn't do it in the right sequence. That's what we do. All right. Here's the weirdest one of them all. The weirdest one of them all deals with standard form.
What were the last two columns?
It was the first one was vertex form, the next one was intercept, and this is standard. Yeah, you want to use a matrix C for this one.
Why is the hard one standard?
That's just how it is.
I couldn't think about it. If standard usually means normal, I couldn't do
So here's where things get interesting. What happens here when you have the standard form of an equation, you are going to wind up creating 3x3 matrices. And you're going to solve a 3x3 matrix to solve for your A, B, and C.
Calculator.
This is all calculator based when you go to solve the matrix out. Because remember how we used inverse matrices to solve equations? That's all we're doing. But you have to come up with the actual sets of ordered pairs to make it work. Okay? So as you start these things out, you are going to use -1 and 5, 0 and 3, 3 and 9 to create 3 separate equations. If you look at this, this is an x and a y. Do you agree? So if I substitute in for x and y in standard form with this set of ordered pairs, it would look like this. I get -1 squared a plus -1 b plus c equals 5. I'm leaving the A, B's, and C's in there. Because I'm creating a system that's going to solve for A, B, and C. Okay? Now, when I go to rewrite this out here, this is my hint. We're going to create a 3 by 3 and use inverse matrices. When I write this out, when I simplify it, I'm going to put it over here. What's negative 1 squared? 1. So I have 1a minus 1b plus c is 5. So there's my first equation. My next equation, I go to the next point. 0 and x and y. 0 and 3. I substitute in for x. So I have 0 squared a plus 0 times b plus c is 3. So c equals 3. So when I'm going into my system, though, because remember, I want to use a matrix for all this, I'm just going to put zeros in. So I'm going to have 0a plus 0b plus c is 3. Now, I could be a real mean jerk and tell you to do all this by hand. I wouldn't do that. That's you can do it by hand. Go for it. And then lastly, I do that again with the third one. I get 3 squared a plus 3b plus c is 9. So that equation would look like, well, what's 3 squared? I have 9a, and I'm sorry that my 9s and my a's might look a little bit the same, plus 3b plus c is 9. So now you have a 3 by 3 with 3 solutions. Everybody see that?
We just do the thing where you the Kramer's rule.
No, don't even mess with Kramer's rule, because here's what I want you to do. If we go to our calculator. What's that?
But wouldn't you have put like 3s for all the c's because we found out that c
No.
equals 3?
No. Don't even bother with that. What's the coefficient for c here? 1. Go right to a matrix, guys. When you go to your matrix, remember the shortcut, alpha zoom? I need to create a 3 by 3. Do you agree with that? 3 variables, 3 equations. We're going to create a 3 by 3. Coefficients, 1, negative 1, 1. I'm going to use 1s for all the c values. Is that all right? Should be. 0, 0, 3, 9, 3, 1.
Wait. You used 3 instead of 1.
Oh, thank you. I said, thank you. I just got out. All right. Now, do you guys remember the rule for when you're multiplying to find the solutions with inverse matrices? What's the next button you press? Inverse. Excellent. Inverse. Now, what am I multiplying that to? Oops. Button. Alpha. Zoom. Now I need to make a 3 by 1. And what are my answers I got to put through? 5, 3, 9. And now what do you press?
We're not gonna have to do this by hand.
No, I'm not going to make you do this by hand. So what do these represent? A, B's, and C's. So now my A value.
Now we have to substitute back in for all 3 equations?
No, because now what you know is that your A is 1, B is negative 1, and C is 3. So if I'm using standard form, well, that's ax squared plus bx plus c. Well, what's A? 1. What's B? What's C? And you're done.
Since you already know C, could you go through and just make it 2 by 2?
Yeah, in this case, yes. But I'm trying to show the whole thing through. You can do a lot of stuff, because this is a very easy substitution problem too. You could have done that in substitution. What's that? You're using a calculator. But it's just, if you look at it, it's just systematic. And I'll tell you one thing, what you're gonna mess up when you're substituting in your values, you're gonna put them out of order or something like that, okay? All right, so your final answer is just x squared minus x plus 3. All right, let's try, I'll let you guys try one like that here. Same idea. Remember, it's ax squared plus bx plus c is your y value. Okay? Take a couple minutes. Now, you want to see a nice, real easy shortcut? When you go through the pattern here, it's x squared plus x plus c, right? Do we know what any of our c values are? What is always c? Okay? Now, if I'm taking this number, because that's x, and I square it, what's negative 2 squared? What's 1 squared? What's 2 squared? What's x? What's x? What's x? Yes? No. What are your solutions? I'm a bad person, yes, and it took you only till November to figure that out.
So the first one is just x squared.
Yep. Yep. Think about what you're doing here. You're taking your x squared times a, x times b plus c. So you're just filling in the blanks as you go through. So if you're doing it with a set of ordered pairs, if you got the order, all 3 points there, square it down the first column. X value is the second one. 1's the thirds. Inverse it times your column of y's. Bada bing, bada boom, and you got what? 371. So it's 3x squared plus 7x, and what was the last one?
Plus 1.
Plus 1. And there's your answer. All right, Bomber, I'll talk slower for you because you like the Packers.
Wow.
What is... All right, here, remember, once again, shortcut. This column is x squared, this column is x, this column is always 1, this column is your y's. Okay? That is the easiest way to remember that one out. I'm going to give you 3 of each of these styles to take care of tonight. I don't think this will take you very long. Tomorrow when we come into class, I've got some modeling problems for us to restart reviewing on, and then start building towards what I want you guys to work on over the weekend for review for Tuesday. I will not, we should test on Tuesday, but that's just me after 4 days off.
Yeah.
So we won't do that. We will still test on Wednesday, and we'll talk more about it tomorrow going into Tuesday. Okay? Yeah. I'm not going to start checking at 6. These are odds for all of these, so you guys can check your answers. I'm giving you all the odds here so you can check all of your answers. Okay?
We have time to work. What time is that?